Hey grade 12s, and welcome. And in this video we'll be looking at additional mathematics, and specifically we'll be looking at the first topic, which is coordinates geometry. So we'll be doing a bit of coordinate geometry, and this is the first topic in additional mathematics, and it's quite easy and quite easy to grasp. Easy concepts, and it's basically what you've been doing in ordinary level mathematics, and that's what we'll be doing. So this is an introduction to coordinate geometry, and so let's get our thinking caps on and let's get into doing some math. So when we talk of coordinate geometry, we are simply talking of the Cartesian plane, which I believe you have come across at least once. So Cartesian plane has got two axes. So we've got the y-axis and we've got the x-axis, and we can identify and can be able to name points within this Cartesian plane that we have, and these points are identified by their x-coordinates and their y-coordinates. So let's say we've got a Cartesian plane that has its x-axis running from 0 to 5. So we've got 0, we've got 5 there, and let's say 1, 2, 3, and 4 there. And we've got our y-axis, which is running from 0 to 5 as well. So we've got 5 there. We've got 1. We've got 2. We've got 3 there. And we've got 4 there. Okay? So if, let's say, we are given a point A, this point A can be identified by its x-axis coordinates and its y-axis coordinates. So A would then have the coordinates 3, 4. So coordinates are always given in the form x, y. Okay? So coordinates are given in the form x, y. So if I was to tell you to say, identify a point which has the coordinates 2, 3, you know that the first coordinate that you have given is the x, and the second coordinate that you're given is the y. So in the x, we have the point 2, so this is the point 2 in the x. So this is the 2 in the x, and the 3 in the y is there. So we'd have something like that. So where these two lines are meeting, or rather intersecting, that would be your point, the point in question, which is point B. So this point would be point B. B having the coordinates 2, 3. This is some really basic concepts that is really important, and it's really important that you get to understand how to identify points on a Cartesian plane, and you get to know how to plot points on a Cartesian plane or a graph. So the y-axis is a vertical axis, whilst the x-axis is the horizontal axis. Okay? So if I was to ask you to say, identify the point C, which has the coordinates 2, 0. 2, 0. So meaning in the x-axis, we're looking for the point 2, and in the y-axis, we're looking for the point 0. So the 2 in the x-axis is the one that we had drawn earlier, whilst the y in the 0 in the y-axis is simply the line upon which this x-axis is lying, or the reference point in the x-axis. So we would have this intersection there, And this intercept is what will be our point C, having the coordinates 2, 0. So I believe this is basic, and you've done this in ordinary mathematics. So this was just a refresher, even as we dwell into additional mathematics, coordinates geometry. So another concept that you have to understand is the concept of what is known as the midpoint. So the midpoint, just from the term itself, the midpoint is simply the center point or the middle point of a given line or a given distance. So if I was to give you a stick which is 3 centimeters long, and I was to ask you to identify its midpoint, you would easily identify its midpoint by simply dividing this 3 by 2. So its midpoint would be 1.5 centimeters from either end of the stick. So the midpoint would be, let's say there, which is 1.5 centimeters from either end. So now let's assume we're given 2 points. We're given a point A as a starting point, and you're given another point, point B, and you're told to say the distance between these 2 points is, so you've got point A there, you've got point B there, and you're told to say the distance between these 2 points is 10 centimeters, right? And you're asked to identify the point C, which is in between point A and point B. So if I was to tell you to say C is directly or is right in the middle of points A and of points A and B, you would easily identify C by saying C is simply half the distance between A and B. So the distance from A to C is half the distance of AB, and the distance BC is simply half the distance AB, which is 5. So C is somewhere there, which is 5 centimeters from A and 5 centimeters from B. Really easy concept, eh? So this is our point C. So now when we're dealing with coordinate geometry, we can identify the midpoint of 2 points that you've been given, and the concept is basically the same as what we have been looking at. So let's assume we are given, a Cartesian graph. We're given a Cartesian graph which is, let me use straight lines for that. We're given this Cartesian graph, and this is a 0 point, this is the x-axis, and this is the y-axis, and we're given 2 points, point A and point B. Point A is 3, 0, right? Whilst point B is 1, 5. So firstly, let's identify the points A and B. So in the x-axis, the highest value that we have is 3, and the least value that we have is 1. So our graph can go as far as, our x-axis can go as far as 5. So we'll have 5 there. So meaning we're going to have our 1 there, our 2 there, our 3 there, and our 4 there. and our y values go as far as 5, and starting from 0, so we'd have our 5 there as the most extreme point, 5, we have our 1 there, our 2 there, our 3 there, and our 4 there, right? So firstly, we identify the points A and B. So for A, we are told A is 3, 0. So the point A would lie right here. Or point A will lie there, right on the 3. And our point B will lie at 1, 5. So our 1 line is there. Our 1 in the x-axis is right here. Okay, and our 5 in the y-axis is there. So we would assume our point B rather, is right at the intercept of those two lines. So our point B is there, right? So we've done the first part, which is identifying the points A and B. And let's say you're asked to say, find the midpoint of A and B. Find the midpoint between A and B. So how do we proceed from there? So the first thing that I would advise you to do is draw a line joining these 2 points, A and B. So drawing a line joining points A and point B. So we would have this straight line joining point A and point B. And so we are asked to find the midpoint between A and B. So by visual inspection, I would guess our midpoint would be somewhere here, somewhere around here. But then how do we find the midpoint mathematically? So when we're dealing with coordinate geometry, as I said earlier, we've got 2 coordinates. We've got 2 coordinates that we are dealing with. We've got the x coordinates and we've got the y coordinates. So for each point that you would identify that should be given, you would have the x and the y. So for A, we've got the x, and for y, we've got the, and for A as well, we've got the y, and for B, we've got the x and the y. So these values that we have on this side are the x values, and the values on the right are the y values. So to find the midpoint, what you need to do is you need to add the x values and divide them by 2, and also add the y values and divide your answer or your sum by 2. And so that will give you an x value as well as a y value. So we would have some midpoint, which I would denote as MP, is equal to x plus x over 2, comma, y plus y over 2. Okay, and that's quite easy. It's simple addition and division. So you're simply adding and dividing. So firstly, identify your x values, then identify your y values, then work them out in such a way. So our x values are 3 and 1. So for x, we've got 3 and 1, got this 3 and this 1. And for the y, we've got 0 and 5. 0 and 5. So our midpoint is therefore equal to our x values, 3 plus the other x value that we have, which is 1, over 2, comma, our y values, we've got 5, or 0 plus 5, divided by 2. So 3 plus 1 gives us a 4 over 2, comma, 0 plus 5 gives us 5 over 2. So 4 divided by 2 gives us a 2, comma, 5 divided by 2 gives us 5 divided by 2 gives us 3 over 2. Oh, sorry, 5 over 2, which is simply, let's just write it in fraction form. So we're going to have 2.5. 5 divided by 2 will give you 2.5. So therefore our midpoint AB, AB equals 2.5. So now let's just compare that with what we had earlier assumed. And our assumption was that the midpoint would be somewhere there. And if we're to identify the midpoint from our worked out solution, we'd say 2, the 2 in the x. The 2 in the x is this point. And 2.5 in the y should be somewhere in between 2 and 3, which is somewhere there. So therefore, the midpoint is that point where these two lines are intercepting, which is MP. So this is quite straightforward. So let's look at another example on how to find the midpoint, how to calculate the midpoint in coordinate geometry. So here's an example. Find the midpoint of A, 3,4 and 5,2. So here's the first question. Find the midpoint of 3,4 and 5,2. So we have the coordinates. So here's our solution. We have the coordinates 3,4, and we also have the coordinates 5,2. So as I said earlier, coordinates are given in the form x, y. So the first thing that we do is we first isolate the x-axis, the x coordinates, and we also isolate the y coordinates. So for the x coordinates, we have, for x we have 3 and 5, whilst for y we have 4 and 2. And I hope you remember the formula that we are using to calculate the midpoint. So midpoint is given by x plus x divided by 2, comma, y plus y divided by 2. So what we get then is the x coordinates, we have 3 and 5, so 3 plus 5 divided by 2, comma, 4 plus 2 divided by 2. So 3 plus 5 gives us 8 divided by 2, comma, 4 plus 2 gives us 6 divided by 2. 8 divided by 2 will give us a 4, comma, 6 divided by 2 will give us a 3. So therefore, our midpoint MP equals 4, 3. Quite easy to grasp. And we can do the second one. And I would advise you to first pause the video and try working it out on your own. And once you're done, you can play the video and try to see and check if we will arrive at the same answer. So for the second part, we are given the coordinates -2, -1, and we are given 4, -4. This is the x, and these are on the y. So for the x coordinates, we have -2 and 4, and for the y coordinates, we have -1 and -4. So you can pause the video, try working it out on your own. So we can get into calculating the midpoint. So the midpoint is given by x plus x over 2, comma, y plus y over 2. So x, what are the x coordinates that we have? We have -2 plus 4 over 2, comma. For the y coordinates, we've got -1 plus -4, and this is divided by 2. -2 plus 4 gives us a 2 over 2, whilst -1 plus -4 gives us -5 over 2. 2 over 2 gives us a 1, whilst -5 divided by 2 gives us -2.5. So therefore our midpoint is given by 1, -2.5. So this decimal part can be given either as a fraction or as a decimal, and that's how we find the midpoint. So now when you're dealing with coordinate geometry and in your final examinations, in your mock examinations, in your tests, you won't get questions that are so straightforward when it comes to midpoint. So let's look at something a bit more complicated, asking us about the midpoint. So here's the next example. So here's a second example. So we're going to look at different examples, and each example will be a bit more challenging than the previous example that we do. So here's a bit more challenging question compared to what we looked at. So this question says the midpoint of PQ is 2, 3. If the coordinates of P are -1, 4, find the coordinates of Q. The midpoint of PQ is 2, 3. If the coordinates of P are -1, 4, find the coordinates of Q. So I'd advise you, pause the video, work it out on your own, and if you don't get it right, or if you're unsure, you can follow me even as we work through it together. So we're given the midpoints of PQ, and we're given the coordinates of P, and we're asked to find the coordinates of Q. So firstly, let's look at what we've been given. So let's say we've got, as usual, we need to identify the x and y. For P, we have 2, 3. So 2, 3 there. And for Q, let's name this as x1, y1. Okay? And we're given the midpoint. Midpoint we are given as, or rather to be 2, 3. So let's write down our equation. We know that midpoint of any 2 points is given by x plus x over 2, y plus y over 2, right? So what are the x values we're given for the 2 points? So for the x values, we've got 2 and x, so we've got 2 plus x over 2, comma. For the y values, we have 3 and y, so 3 plus y over 2. But we are also given the midpoint values, which are 2, 3. Right? Then what do we do from there? So this is supposed to be x1 and this is y1. Then what do we do from there, grade 12s? So what we do from there is that this value can only be gotten from this part of the equation, and this value can only be gotten from that part of the equation. So we equate the x value of the midpoint to the calculation part of the x, and we equate this value to that part. So we have this. So let me do this. So this was found from that, whilst this was calculated from that. So from there, what we do is we equate the 2 to the 2 plus x over 2, and comma the 3 to the 3 plus y over 2. So 3 equals 3 plus y over 2. Simple. Is it simple from there? Is it simpler from there? Does it get easier to work around from that point? Definitely. So we will say 2 multiplied by 2, which gives us a 4, equals 2 plus x, comma 2 multiplied by 3, which gives us a 6, equals 3 plus y1, x1, x1, y1. Okay, equate, rather group the like terms. We have x equals 4 minus 2, so x1, comma y1 equals 6 minus 3. Therefore, we get x1 being equal to 2, comma y1 equal to 3. Are we together? So therefore, the points, coordinates of point Q are 2, 3. And that is how we work around that question. Did you get 2, 3? If you didn't get 2, 3, you can rewind this video and try to grasp the concept. So let's look at question number 3. So here's our third question. Question 3 says ABCD is a parallelogram. A is a point 2, 5, while B is a point 8, 8, and the diagonals intersect at 3.5, 2.5. What are the coordinates of C and D? So A is a point 2, 5, while B is a point 8, 8. So firstly, let's make sure we all know how parallelogram looks, or what a parallelogram looks like. So parallelogram is simply a four-sided shape, or not like that. Okay, let's assume. Okay, so parallelogram is a shape that looks something like this, and we've been told to say it's got points A, B, C, and D. We're given the coordinates of A. Coordinates of A are 2, 5, and the coordinates of B are 8, 8. Okay? And what else are we given? We're given the point at which the diagonals intersect. So when we talk of diagonals, we are simply talking of straight lines running from this point to that point. Maybe let me draw them in a different color. Let's say red. Let's draw them in red. So diagonals are simply points running from one point to the opposite point, like that. Okay, and we are given the points, the coordinates of the point of intersection of these diagonals, which is there. And we're told to say this is 3.5. Okay, so let me do this. We're given that point to be 3.5, 2.5, right? So these are the types. This is the type of question that you should expect in your tests, in your mock examinations, in your final examinations. So it might seem a bit complicated at first value, but you will notice that once you give yourself such a drawing, you do something like this, you would have done half of the work, because this has simplified the work way more than it would have been if you didn't have the drawing. So the first thing that you do is just try to draw what you're given, put the information that you've been given into something that you can see, some visual representation of the information, and that is in drawing form. And from there you can work it out. So if you feel you're confident enough, you can pause the video and try working out this question. So we've been given that parallelogram, points of the parallelogram, we've been given the points of intersection of the diagonals as well. So how do we proceed from this point? Well, if we're given the point of intersection of the diagonals, it simply means we've been given the midpoints of the diagonals. So these points, these diagonals are intersecting exactly at the middle of the drawing, at the center of the drawing, which is also the center of the two diagonals that we have, the midpoints of the two diagonals that we have. So in short, we've been given the midpoints of point A and point D. We've also been given the midpoints between point C and point B. And these midpoints are the same, 3.5, 2.5. So let me just move this drawing up. Maybe we can leave it there, and we can work out this problem here at the bottom. So let's start with first identifying point D. So what information do we have to identify point D? We've been given one point, the midpoint, and we're looking for the other point. So this question is exactly, or rather let me say, is similar to the previous question that we just did, where we had been given one point, the midpoint, and we're asked to find the other point. And so we can collect our data. Remember, we've got X and Y. Then for the first point, which is point A, for A we've got 2, 5, right? And for D we have, so for D, since this is what we're looking for, we're going to give them any values that we feel like giving them. So let's assume them the coordinates to be x1, y1. And what else are we given? We're given the midpoint. The midpoint in this case is 3.5, 2.5. 3.5, 2.5. And we can work out from there. So MP equals x plus x over 2, y plus y over 2. So what are the x values that we have? We have 2 and x. So we have 2 plus x1 over 2, y. What do we have in the y? We've got 5 and y1. So 5 plus y1 over 2. And what do we have as our midpoints? We've got 3.5, 2.5. So just as we had worked it out in the previous example, the x part of the midpoint corresponds with that part, whilst the y part corresponds with that part. So we have 3.5 being equal to 2 plus x 1 over 2, comma, 2.5 being equal to 5 plus y 1 over 2. So we cross multiply. 2 multiplied by 3.5 gives us 7 equals 2 plus x1, comma, 2.5 by 2 gives us 5 being equal to 5 plus y1. We group the like terms. We will therefore have x equals 7 minus 2, which gives us 5, comma, x1, y1 equals 5 minus 5, which gives us 0. So therefore, the coordinates of D are 5, 0. And from there you can find the coordinates of C as well using the exact same procedure. So let's just work that out real quick. Let's just work that out real quick. So we use the exact same procedure, and we said we first start with identifying the x and the y in the coordinates that we've been given. So for C, we are going to use the coordinates of B and the midpoint coordinates. So for B we have 8, 8. For C, let's name them x2, y2. And for the midpoints, we have the same coordinates, which are 3.5, 2.5. And we do the exact same thing we just did to find D, and we said midpoint equals x plus x over 2, y plus y over 2. So what are the x coordinates? X coordinates, we have 8 and x2, so 8 plus x2 over 2, y, which is 8 as well, plus the other y, which is y2 over 2. And for the midpoints, we have 3.5, 2.5. This corresponds with that, and that corresponds with the other one there. So we have 3.5 equals 8 plus x2 over 2, 2.5 equal to 8 plus y2 over 2. So 2 multiplied by 3.5 gives us 7 equals 8 plus x2, 2.5 by 2 gives us a 5 equals 8 plus y2, right? And so our x2 equals -1, our y2 equals -3. So therefore the coordinates of C are -1, -3. And that is how we work out this particular question. And if we were to look and examine the answers that we have, if we look at the answers that we've gotten and we examine them, you would find that they are logically making sense, they are logically correct, because when you look at C, C is outside, right, outside the area in which A is located. So it would make sense that C has an x value of -1, and it would make sense that C has a y value of -3. Okay? So that is how we work out this problem. And let us see what we can do next. So friends, this is the last example that we're looking at on the midpoints, and you can pause the video and try working this out on your own. So the question says the points x1, y1, x2, y2, x3, y3, x4, y4 in that order form a parallelogram ABCD. Show that x1 plus x3 equals x2 plus x4 and y1 plus y3 equals y2 plus y4. So here's the last example that we're doing. And so you can pause the video, work it out on your own. Okay, so welcome back. And so let's see how we can work this question out together. So given the points x1, y1, x2, y2, x3, y3, and x4, y4. So let's first start with drawing the parallelogram that we are given. So here's our solution. So let's draw that parallelogram again. So here is a parallelogram, and let's just, the parallelogram is there. So we have the first point x1, y1, x2, y2, x3, y3, and lastly x4, y4. And we're asked to prove that x1 plus x3 equals x2 plus x4, and y1 plus y3 is equal to y2 plus y4. So how do we go around and how do we go about proving that? Let us think. So firstly, let's refer to the previous example that we just did. We agreed to say, given a parallelogram, you would have diagonals. You'd have diagonals stretching from one end to the other end, and another diagonal from one end to the opposite end. And in the previous example, we agreed to say these diagonals have a point of intersection, and that point of intersection is also acting as the midpoint of both diagonals. So these diagonals are meeting there. These diagonals are meeting right there. And if they're meeting right there, this is the midpoint of this diagonal, and it is the midpoint of that diagonal. So we agreed as well to say the point of intersection of the two diagonals is a mutual midpoint of both diagonals, and this means their midpoints are equal. So a midpoint between points, let's name this as point 1, point 2, point 3, and point 4. So the midpoint between point 1 and point 3 equals the midpoint between point 2 and point 4. So midpoint between 1 and 3 equals midpoint between 2 and 4. So how do you find the midpoint between 1 and 3. Midpoint between 1 and 3 is given by, firstly, midpoint is given by x plus x over 2, comma y plus y over 2. So for 1 and 3 would have x1 plus x3 over 2, comma y1 plus y3 over 2. This is y3. And this is equal to midpoint between 2 and 4, which is x2 plus x4 over 2, comma, y2 plus y4 over 2. Okay, and we can equate the x's and equate the y's, so we'd have x1 plus x2 or plus x3 over 2 equal to x2 plus x4 over 2, and would also have y1 plus y3 over 2 equal to y2 plus y4 over 2. So we can multiply both sides of the equal sign by 2, and we would have x1 plus x3 equal to x2 plus x4, and would have y1 plus y3 equals y2 plus y4. And this is the same as what we have in the question, and hence we have shown to say this x1, x3 equals to the sum x2, x4, and y1 and y3 equals to y2 and y4. And that is how we go about proving and showing that two points of a parallelogram are equal to two other points of a parallelogram. And this was an introductory video, and we just looked at the first concept in coordinate geometry. And so in the next video, we'll look at the next concept in coordinate geometry. And so thank you very much for watching, and hope you subscribe, and hope you continue viewing our content. Thank you and goodbye.